Now we are going to study about displacement reaction. See, displacement reaction means a reaction in which one metal substitute or displace other metal from a salt. Are you clear? I will write here. See, zinc. Zinc is a metal, or I will write another example, Fe. Fe is a metal. When I am treating this iron with copper sulfate, see, copper sulfate means it is a salt. This salt is having a metal copper. So when iron reacts with copper sulfate, the copper sulfate is blue in color. When iron reacts with copper sulfate, see, the iron displaces copper from copper sulfate. So we will get at the place of copper, the iron goes and attach. So what happens? It becomes FeSO4, become FeSO4 iron sulfate, and the copper will be displaced plus copper. Okay, this is called displacement reaction. You see, from copper sulfate, the copper is displaced by iron. From this reaction, we can understand one factor. Why this copper sulfate? From copper sulfate, copper is displaced because iron is more reactive than copper. So a more reactive metal displaces less reactive metal from its salt. Okay, a more reactive metal displaces less reactive metal from its salt. This reaction is called displacement reaction. So displacement reaction we can use for finding out which metal is more reactive than the other. So here iron displaces copper from copper sulfate, therefore iron is more reactive than copper. Okay, by doing this displacement reaction, we can find out the order of reactivity of metal. That means we can arrange the metal from high reactivity to low reactivity. Such arrangement of metals based on its reactivity is known as the reactivity series of metals, or it is called activity series of metals. We can find which is the most reactive, next reactive, next one, and we can find arrange the metals from the most reactive to least reactive. That arrangement is known as the activity series of metals. So in order to find out the activity series of metal, this reaction is very, very helpful. See children, now I will show you the same reaction, how iron is displacing copper from copper sulfate solution. See, the copper sulfate is blue in color. Okay, copper sulfate is blue in color. Okay, the blue color copper sulfate is this. And see, in my hand, this is iron powder. Okay, this is the iron powder. You can see the iron powder. Okay, this is the iron powder. Now what happens, you see, I am taking copper sulfate solution, okay, in a test tube. I am taking copper sulfate solution. See, the blue color copper sulfate solution I have taken. Are you clear? Now see, I am putting some iron in it, iron powder. Slowly I am putting iron powder in it. Okay. After some time, what happens, you see? Shake it well. Okay. Shake it well. See, now itself you can see the blue color is gradually changing into green. The blue color is gradually, see the blue color, copper sulfate is blue, now it become green. Okay, the gradually it is changing. Why the blue become green? See, because iron sulfate is forming. Iron sulfate is green in color. Okay, iron sulfate is green in color. Why? Because in copper sulfate, the copper is being replaced by iron. Copper is being replaced by iron, and we are getting iron sulfate. See now, the green color is very prominent green color. Okay, the green color, iron sulfate you are getting. From this what we can understand? We can understand that iron is more reactive than copper. That's why it becomes iron sulfate. And if you clearly see, we can see the copper particles. Copper is getting separated. Copper particles are separated. And here you can see the green iron sulfate. From this we can understand that iron is more reactive than copper. That's why iron displaced copper from copper sulfate solution. That's why it is called displacement reaction. See now the same copper sulfate I am taking. The copper sulfate is blue in color. Now I am taking this copper sulfate in a test tube. The blue color copper sulfate solution I have taken. See now let us see zinc. Another metal I am putting. Okay, let us see whether zinc can displace copper sulfate or not. I am putting, see the zinc granules. Okay, zinc granules I am putting inside the copper sulfate solution and I am shaking it. Okay, slowly I am shaking it. Let us see what happens after some time. See, gradually the color is reducing. Okay, gradually the blue color of the copper sulfate solution is vanishing. Okay, slowly the color is vanishing. Just you come back. Okay, let us wait for some more time. Okay, I am shaking. The color inside the see zinc, you see the zinc color also changes. Now you see, now copper sulfate, this one copper sulfate, it is blue, but this become colorless. This become colorless. Why? Because zinc displays copper from copper sulfate and it gives zinc sulfate. Okay, it gives zinc sulfate. So from this what we can understand? We can understand that zinc is more reactive than copper. Are you clear? Even zinc is more reactive than iron also. It comes above iron in reactivity. So we have taken zinc, Zn, and we added zinc into copper sulfate. So CuSO4, copper sulfate. Copper sulfate is actually blue in color. And zinc being more reactive displaced copper from copper sulfate and produced zinc sulfate. Zinc sulfate, you see, it is colorless. But see, this is blue in color because copper sulfate. Now it became colorless. Why it is colorless? Because zinc sulfate is colorless. Zinc sulfate is colorless. Copper is being displaced by zinc and zinc sulfate and copper are formed. From this reaction, from this displacement reaction, we can understand that zinc is more reactive than copper. Are you clear? See, next we will study about double displacement reaction. Earlier we studied displacement reaction, that is single displacement. There we have taken one of the reactant was metal and another one was a metallic salt. Say for example copper sulfate. Copper sulfate is a metallic salt. Here I will explain you the double displacement reaction with an example. You see, Na2SO4 is a salt. This is called sodium sodium sulfate. Okay, Na2SO4 is sodium sulfate. It reacts with another salt. Okay, that is BaCl2. BaCl2 is barium chloride. Okay, barium chloride. BaCl2, barium chloride. So here the reactants both are salts. When two salts are joined together, when the two salts are react together, what happens you see? Na2SO4 plus BaCl2 become BaSO4 plus NaCl. That means, see, the place where barium is there, where the sodium will attach, and the place of sodium will be occupied by barium. There will be substitution, there will be mutual exchange. At the place of barium, sodium ion will attach, and at the place of sodium, barium will attach and form sodium sulfate become barium sulfate. Barium chloride become sodium chloride. Okay, so here exchange took place between two salts. There is exchange between sodium ion and barium ion. So such a reaction in which exchange of ions takes place between two salts. Exchange of ions takes place between two salts. Such a reaction is known as double displacement reaction. See here, which are the two salts? Example, sodium sulfate is a salt, barium chloride is another salt. Here the exchange took place between sodium ion and barium ion. Sodium sulfate become barium sulfate, barium chloride become sodium chloride. Are you clear? So a chemical reaction in which two salts react together and there will be exchange between two ions, then such a reaction is known as double displacement reaction. Here, when sodium sulfate reacts with barium chloride, you are getting barium sulfate. See, the barium sulfate is a precipitate. What do you mean by precipitate? Precipitate is a solid substance that settles at the bottom of the test tube. After a reaction, when a solid substance settles at the bottom of a test tube, then that substance we will call it as precipitate. So, barium sulfate is a precipitate. It's a white precipitate. Barium sulfate. Okay, it's a white precipitate. I am writing white PPT, white precipitate. And sodium chloride. Okay, sodium chloride. Therefore, mutual exchange took place and this reaction is known as double displacement reaction. Since this reaction involves the formation of a precipitate. What do you mean by precipitate? Precipitate means a solid substance which settles at the bottom of the test tube after a chemical reaction. Okay, if any chemical reaction that results in the formation of a solid residue or a precipitate at the bottom of the test tube, then that is known as precipitate. Since this reaction involves the formation of a precipitate, this reaction is called precipitation reaction. So this reaction is also an example for precipitation reaction. Why this is called precipitation reaction? Because one of the product form is a precipitate. It's a solid residue that settles at the bottom of the test tube. So a reaction that involves the formation of a precipitate is known as precipitation reaction. Therefore, this particular double displacement reaction is also an example for precipitation reaction. If they are asking for, write an example for precipitation reaction, you can write sodium sulfate. When reacts with barium chloride, barium sulfate is formed as a precipitate. That means barium sulfate is formed at the bottom of the test tube as a solid residue. That is called precipitate. And this kind of reaction is called precipitation reaction. Okay, double displacement reaction means a reaction between two salts where there will be exchange between ions is known as double displacement reaction. In this reaction, the exchange took place between sodium ion and barium ion. Therefore, sodium sulfate becomes sodium chloride, barium chloride becomes barium sulfate. Okay, such reaction are called double displacement reaction. Another example for double displacement reaction, let us see. See, PbNO3 twice. PbNO3 twice is lead nitrate. PbNO3 twice is lead nitrate. Lead nitrate is a salt. It is reacting with another salt, that is potassium iodide, Ki. Ki means potassium iodide. Okay, potassium iodide. See, when lead nitrate reacts with potassium iodide, what happens, you see? There is displacement, double displacement takes place between lead Pb and K, potassium. See, lead move to the place of K and displace K. K come at the place of lead Pb and form, see, lead nitrate. It become, see, it occupies the place of K and form lead iodide. Okay, PbI2 means lead iodide. Lead iodide is yellow in color. It is an yellow. Okay, lead iodide is an yellow precipitate. Precipitate means we can denote by a downward arrow. Downward arrow indicates that it's a precipitation reaction. Which is the precipitate? Lead iodide is the precipitate. What is the color of lead iodide? Yellow. So yellow color precipitate is formed, that is lead iodide. And see, potassium iodide become, at the place of potassium, lead comes. Okay, so it become potassium nitrate. Okay, it is potassium nitrate. Therefore, this is also a double displacement reaction. You see, the reaction between two salts, lead nitrate and potassium iodide, where there is exchange of ion took place between lead and potassium, and we are getting lead iodide. Lead nitrate become lead iodide, potassium iodide become potassium nitrate. Therefore, this is another example for double displacement reaction. In this reaction, the lead iodide formed is a yellow precipitate. Okay, lead iodide formed is a yellow precipitate, that is precipitated at the bottom of the test tube. Therefore, this is also an example for precipitation reaction, a reaction in which precipitate is formed. Are you clear? This question is there. What type of reaction is the reaction between lead nitrate and potassium iodide? It is a double displacement reaction. It is also an example for precipitation reaction. Why? Because lead iodide is formed as a precipitate. What is the color of lead iodide? The color of lead iodide is yellow. How can we balance this equation? Try to balance this. See here, PbNO3 twice. NO3 twice means this 2 is common for both N as well as oxygen. 2 nitrogen are there and 3 into 2, 6 oxygen are there. So here 2 nitrogen is there, but you see here KNO3, only 1 nitrogen is there. So we will put a 2 here. When you put a 2 there, the nitrogen become 2 and oxygen becomes 6. 2 3s are 6, 2 3s are 6. Nitrogen become 2, nitrogen are 2. But what about potassium? Potassium here only 1, K. But if you put a 2 here, the 2 is common for even potassium. So K become 2. So what you have to do? We have to put a 2 here, 2K. So when you put 2K, this 2 is common for I also. So 2I. Here already PbI2, I2 are there. Now the equation is balanced. Okay. This is how we can balance this chemical equation.